So now let's start our Kahn's algorithm. So our Kahn's algorithm only works at DAG, which is directed acyclic graph. So it should be directed graph. You know, right? What is directed graph? And acyclic, but that means it should not contain any cycles. So our Kahn's algorithm can be used when we are having DAG. So basically, what is this algorithm? Why we use this algorithm? So this algorithm is used to write topological sort. So I have discussed about this, right? Topological sort. So this topological sort is one of the main questions, one of the main topic which will be asked in interviews or the like main questions related to graph concept. So how we will write the topological sort? We will write by using Kahn's algorithm. So before knowing Kahn's algorithm, we should know what is topological sort and how to write it. What does it mean? Basically, what it states is if we are having a graph wherein U is connected to V, again U is connected to V, then in topological sort, U should always be behind V. I know no one understood this one. So what it says is if we are having a graph A, B, C. So suppose A is connected to B, B is connected to C, this is connected to C. This is our graph. This will only work at a circle, right? No cycle. So if this is our graph, this is a acyclic, directed acyclic graph. So now we can use topological. What this means is if A is connected to B, assume it as U is connected to V. That means in our sorting technique, U should be always be behind B. So this A should be always behind B. No matter if we are having any elements inside in between these two elements, that doesn't matter, but always A should be behind B in a sorting technique. In in topological sort means we have to write in linear format. So we can write this in A, B, C, or we can write B, A, C, or we can write C, A, B, C, B. So there are many ways we can write it, right? What is the correct way? What is the topological sorting way? The topological sorting way states that if U is connected to V, then U should be always be behind B. In between, there may be a number of things, but you should not write B again in front of somewhere A should be not present. That's it. So for this, what we can write, A should be always behind B, then we will change our UV. Now let's say this is U, this is V. Okay, so what it says, B should be always behind C. So B should be always behind C. Again, we will change our U and V. We don't have any U and V. So basically, this is our topological sort. What is it? A passing to B, passing to C. Let's just see one more example. If we add D also here, we will put this also here, and we will add E also here. We will put this also like this. At that time, what we will do? Again, what we can do? We have to write our U and V, right? So, what are the criteria to take U? What are the criteria to take U is, in this one, we have to check the in degree. What is in degree? We have discussed it in Our first class related to graph, terminologies of graph. So the number of incoming edges to a particular vertex is called integer of that vertex. When we consider A, right? A, how many edges are incoming edges? Here we are not having any incoming edge. There is only one edge which is outgoing edge. So the integer of A is 0. When it comes to B, how many incoming edges are there? 1. When it comes to C, how many incoming edges are there? 2. Here again 0. Here 1. So this is our integers. Now what we will consider? Let's consider this as U, this as V. So what does topological sorting say? A should be always be behind B. Next, if we update our U and V, suppose this is our U, this is our V. Then what it says? Our B should be always behind C. Let's come here. What does this say? Our D also should be always behind C. So our D also should be always behind C. When it comes to here, what it says? Our D should also be always behind E. Our D should also be always behind E. So what we can get? We can get D here also, we can get D here also, we can get D here also. No matter where we insert our D, but the condition is D should not go in front of C. That's it. So one answer is D, A, B, C, E. For E, we don't have any other option. We have to insert it here itself. Okay. So I guess we can just sort this one. We can just swap this one. E here and C here. That is also one of the option. I think you guys understood the topological sort. What is the condition that is to be needed to write the topological sort? So this is a basic introduction related to topological sort. Now how we will solve topological sort using Kahn's algorithm is, I'll directly explain you the dragoning concept, like how it does, how we will solve. Then you will understand the algorithm. So this is our given graph. This is our given DAG. Now what we have to write? First we have to write the integer of each of the thing. So what does our Kahn's algorithm say? Write integer. So what is our integer of B? Let's start with A, or we can start with any place. Let's start with A. What is our integer of A? Come on guys, what's the integer of A? How many incoming edges A is having? 1. So the degree of A is 1. Likewise, the degree of B is 0. The degree of D is 1, 2, 3. So 3. The degree of C is 1. The degree of E is 2. The degree of F is 1. The degree of G is 2. I think you understood how we write the integer of each vertices. If you are having any doubt, you guys can ask. This by green pen I have written the integers of each vertices. Now what we have to do, we have to take the least vertex. Okay, according to this algorithm, Kahn's algorithm, what we have to do, we have to take the least vertex having degree 0. So now what we have to do, when it comes to DAG, right? When it's come to DAG, we will be having at least one vertex with integer as 0. That is compulsorily. In DAG, in compulsorily, we will be having at least one vertex having integer 0. So we have to start from that vertex. Now what we have to do? We have to take a queue, and here we'll be getting our answer, or let's say our topological sort. Okay. So what this Kahn's algorithm says is, take one vertex which is having 0 degree and push it in our queue. Okay. So now when we are having elements in queue, what we have to do? We have to pop it and put it in our topological sort. So after popping it, what we have to do? We have to remove it from our main graph also. So we remove RB from main graph also. Now what we will be having? We have to find integer of each vertex again, because we don't have one vertex now. There may be changes in integer of each vertex. So what we have to do? We have to find the integer of each vertex again. So what is the integer of A now? 0. What is the integer of C now? 1. Integer of this 2. Integer of this 2. Integer of this 1. This 0. Next what we have to do? We have to again, if our queue is empty, what we have to do? We have to again take a vertex which is having least degree. So here A is having least degree. In degree, we will write it in queue. And then after getting it in queue, what we have to do? We have to again pop it in a queue and add it in our answer. So when we pop it, first we will add it in our answer, then we will delete it from our graph. Again, we have to check all the integers of each vertex. What is the integer of D now? 1. What is the integer of C? 1. What is the integer of E? 2. What is the integer of G? 0. This 1. Again, what we have to do? If our queue is empty, again we have to insert a vertex which is having integer 0. So next we have to pop it and push that number in our answer. After popping it, what we have to do? After popping it, what we have to do? We have to remove that vertex from our given graph also. Now we have to write our integers again. So what is the integer of D now? It's 0. What is the integer of C? Still 1. Integer is still 2. This one will also be 0. So now what we have to take? Again take a vertex which is having least integer as 0. So that is D. We will write it in Q. Next what we will do? We will delete that from Q and delete that from our graph also. We will write it in our answer. Now what is the integer of C? 0. What is the integer of A? It will be 1. What is the integer of F? 0. So again we will take C, we will keep it here, we will delete that from the graph, we will have answer C. Again we will take this, we will keep it in Q, we will pop it, our answer will be F. When we delete this from graph, the what will be the integer of e? It will be 0. It will come here. We'll pop it. We'll come here. We will get e. So this is our topological sorting. What is our topological answer? Sorted answer: B, A, G, D, C, F, and E. So this is our Kahn's algorithm. I'll repeat all the steps again in a similar way. What we have to do, we have to first find the integer of each vertex, and we have to take the vertex which is having an integer of 0. We have to push it in a queue. When we are having elements in queue, what we have to do, we have to pop one element from that queue and push it in our answer. After pushing it in our answer, what we have to do, we have to delete that particular vertex from our graph and again find the integer. If again we have to push the elements having 0 as integer in our queue, then till our queue becomes empty, we have to push it, pop it and push it in our answer. We have to repeat these steps again and again till all the vertices are being pushed in our answer. So this is our Kahn's algorithm. If you are having any doubt, you guys can ask.